Okay, so now what we're going to do, let's have him jump. But before we do that, we're going to implement velocity as we saw before, so a variable. So having him move down by 1 every time is not how you normally move with gravity. You accelerate. Gravity makes you accelerate. So let's try moving. So first we want him to move slow, and then we want to accelerate down faster and faster and faster until he hits the ground. So we'll make a variable. We'll call it fall speed. So your fall speed is always going to start off at 0. So let's set the fall speed to 0 at the start of the program. Now, let's consider the conditions here. If we're touching the ground, then our fall speed should be set to 0. So if I'm touching the ground, I'm not falling. So I will stop falling, basically, when I'm touching the ground. Now, otherwise, if I'm not touching the ground, my fall speed should slowly be increasing. So let's go with 0.1 to start with. So now we are taking control of our variable, and we're saying falling speed is going to be increasing as long as you're not touching the ground. Well, now we need to change your position. This is the Y position, so to make you fall. So this is the code that makes you fall. So let's say we're just always doing this. So I'm going to put that down in here, and I'm going to put this in here. So here's the forever loop. The first thing it does is it says, whatever's happening, I want you to fall down by what? By your fall speed. So, oops, I put that in the wrong place. I need to put it in here. So every time round this loop, 10 times a second, 100 times a second, however many times it goes around this loop, it's going to be changing your Y position. And it's going to change it based on your fall speed. So assuming you're on the ground, you're going to have 0 fall speed. So this should have no effect if we're on the ground. If we're in the air, so not touching green, then our fall speed is going to be rapidly increasing, and we should, as a knock-on effect, start falling. So hopefully this works. It does. Bam. Brilliant. So we see, if you do this yourself, you'll see how he rapidly falls and he accelerates down the way. That's brilliant. So now let's build in some physics for jumping. So we will go with the up arrow for that, I think. Let me just stop this. So the up arrow will be our jump. Or we go with space. Space is a good arrow for... No, we'll go with up arrow, actually. Up arrow is good, yeah. So up arrow for jumping. Well, what happens when we jump? When we jump, simply, we start going up, right? So if your fall speed is how far you're going down, if we add a negative fall speed, that's similar to going up the way, right? Because if we're on the ground, our fall speed will be 0, and then if we put in that as negative 10, then he should start zooming up into the sky. Well, let's see if that's what happens. Well, let's set full speed to negative 10. Negative 10. Okay, fingers crossed that's what happens. Wow, he zooms straight up into the sky, and we can see his full speed goes down. Now that's quite a big jump. It's so big in fact that he's thumped his head off the ceiling. So let's go with negative 5. See if we can set something more reasonable here. So up, makes him jump. He comes back down again, jump again, and he's stopped moving. See if we can jump onto the ladder. We can. Jump up again, and we've come down. We're falling. Now let's have him turn round at the moment. So he's currently facing in the wrong direction. So how can we have him turn around? Well, that's going to require some complicated logic. Let's have a think about this. So we're going to have to record the current direction he's facing in. So let's see if we can't figure out what direction he's currently facing in. So the direction he's currently facing in is going to be under motion, I imagine. And in fact, there's the direction there, direction 90. So if they press the left arrow and our direction is not 90, let me work this out. Okay, so turning him round, first of all he's going to turn upside down, so let's fix that. So now he's going to turn left and right. Brilliant. So turn right, turn left. And we can see here that the direction goes from 90 to negative 90. Okay, so let's just work out in Notepad what I need to do. So if direction, so let's write this down. If your direction is 90, that means facing right, then when they press the left arrow, we should be turning round. And if your direction is negative 90, facing left, and they are pressing the right arrow, we should also turn around. Okay, so let's have a look at our code here and see if we can identify where these are happening. Well, there's when they press the right arrow. So they're pressing the right arrow, and now we need to check their direction to see whether or not we need to turn around. So let's put in an if statement in there. Go with a control statement, put in an if statement. Okay, so if the direction, now we need a comparison in here, so we'll have to use the operators. So there's the equals. We should have seen that under the if statements. So if the direction is, now this is when they've pressed the right arrow, so we're worried about if they're facing left. So if he's facing left, we can see his direction is negative 90. So if his direction is negative 90, we want to set his direction to 90. Point in direction 90. So let's double check that works. So he's now facing left. I'm going to press the right arrow. Brilliant, it works. He's turned around. So let's copy that bit of code. So just drag it out there, duplicate it. So that's our direction for right. There's our direction for left. Now in the left case, we're worried about when he's pointing in direction 90, which is when he's pointing to the right. And when he's pointing to the right and he's pressed the left arrow, then we need to change to negative 90. Okay, so let's see how this does now. Well, we can jump and we can turn round. So this is us created an exciting jumping shooter. And if you can do this kind of a script on your own, then you're in a really good state to start Java programming next week. Now, you could also implement velocity to the right and the left. So we could have, instead of setting your x position by +1 and x position by -1, we could change the velocity x, which is left and right, as we saw with the spaceship example. So I'll leave you guys to do that. If you manage to do that, then post it to me and I'll put it up on Blackboard. Now, one of the things is to do with the assignment is you might not be able to upload an SB file onto Blackboard. So if you can't do that, then just email it to me. Okay, so this is quite a complicated script, but if you sort of have a think about it, you'll get your head around it slightly better. Now, one of the problems is that our for condition is that we're touching green, and the middle of our head can be touching green. So one of the handy little hacks for getting around this is to have the sensing color is touching color. And if you do that, then you can put a little single pixel under his foot that is of that color, and when that colored pixel touches the ground, then you'll know his feet are on the ground. So actually, yeah, let's do that. Let's quickly do that. So I will just, so let's disable his let's disable his costumes for just now. And we'll select costume 1 and we'll edit it. So in this case I'm going to put a single yellow pixel under his foot. Yellow is a terrible color actually because we can't see it properly. So we'll go with blue. There's his blue pixel, single blue pixel. That tiny little blue pixel. Make sure you're on high resolution when you're watching this video. So let's get rid of this costume section. So he's just going to have that. Now we are going to use that sensing condition. Color is touching color, and we will put that as our new fall condition. So our fall condition is no longer touching the green. It's when a specific color, which will be the blue, is touching the green. Get it there, perfect. So hopefully now he should fall until he touches the ground, and he should be able to fall off ledges as well. Yeah, and you'll see it missed that collision in this case because he was moving too fast. He moved through the ground. So this may not actually be the ideal solution because when your fall speed is too high, you can actually clip straight through the terrain. So you might want to make your terrain solid, for example. Now if you want to be able to move up with the gradient of the terrain, then you're going to have potentially a harder problem, because when you're moving down, it's simply a matter of falling down, but moving up, slightly more difficult. So if anyone solves that problem, feel free to let people know. Okay, so hopefully this is an example of a more exciting, more complicated script with a character that's genuinely quite exciting and fun. So I'm just going to fix this again, and then I'm going to upload this to Blackboard so that you guys can download it and test it out for yourselves. And you can see how he moves and how he is basically slightly more exciting. I better hit stop here and hit go. There we go. So now he's running properly. And he's running excitingly again. Okay. Thank you very much, and hopefully this has been informative and exciting and interesting.